Hello everyone, I am Sangameshwar Patil. I will be presenting our paper under the journal First Track at the virtual IEEE 2020. The slides contain more details for the sake of completeness and offline viewing. I will be able to focus only on the important points from the slides. Software defect classification is an important part of SDLC with multiple benefits. There is an increasing need for its automation as the manual classification process is expensive, time-consuming, and needs specialized expertise. Multiple defect classification schemes have been proposed in the literature. In this paper, we focus on classifying the defects along the defect type dimension. IBM ODC is among the well-known schemes. Thung et al. Have proposed a customized defect classification scheme based on IBM ODC. They have aggregated fine-grained defect types into three broad defect families, as shown here. The IEEE 1044 standard also provides a sample classification scheme as shown here. The goal of this paper is to automatically predict the defect type of a software defect using the textual descriptions. As an illustration, the table shows the three sample defect types classified using the IEEE scheme as well as the customized scheme used by Thung et al. To establish the current state of the art. Our approach is motivated by the observation that human experts do not need much label training data for the defect classification. Plausible explanation for this is suggested by Gabrilowitsch under the explicit semantic analysis framework. ESA is based on the observation that humans judge the semantic relatedness at a conceptual level. For instance, we treat car and truck as more similar than say truck and infection. ESA framework approximates the amorphous abstract human concept space using the Wikipedia to get a computationally amenable representation. They assume that a Wikipedia article can be considered as equivalent to a concept in the human concept space. Given a text fragment, ESA represents it computationally as a vector of most relevant Wikipedia articles along with their degree of relevance. We use this property for the software defect type classification. A defect and a defect type are considered similar if they share common Wikipedia concepts in their ESA representation. The proposed approach can be summarized into following three high-level steps. First, a one-time preprocessing activity that creates an inverted index from the input Wikipedia corpus. Then, we create concept-based representations of the input defect as well as each defect type label. Finally, we identify the most relevant defect type label using the decision function as shown here. Creation of the concept-based representation involves three basic steps: identification of Wikipedia articles for each term in the input document, quantification of the strength of association, and finally, aggregating the individual term scores into a document-level relevance score. To speed up the computation, we pre-process the Wikipedia dump into an inverted index. This slide shows common concepts between a sample defect and different defect types as well as their relevance weights. Details of the table are available in the paper. For validation of the proposed approach, we use two software defect datasets and two different schemes. The Apache Libs dataset is the standard benchmark used to establish the current state of the art. The second dataset has defects from the Roundcube webmail software. We use the classification schemes proposed by IEEE as well as Thung et al. The distribution of defects in the gold standard datasets is shown in the table. Comparison of the features used and the accuracy of the proposed approach and the baselines is highlighted in this table. In spite of using significantly constrained input and without access to the bug fixing source code, the accuracy, that is F1 score of the proposed CBC approach, is comparable with the state-of-the-art LEDEX approach. The SVM based approach needs 90% of the label data for training and is not viable in practice. The CBC approach needs only the keywords and phrases describing the defect type labels and the defect description. The state-of-the-art needs the text as well as source code used to fix the bug. So unlike the state-of-the-art approach, our approach can be used before a defect is fixed. This is an important advantage in the practice. This table compares the proposed approach on all the combinations of different datasets and classification schemes. From this table, we note that the CBC approach is a viable alternative to the state-of-the-art. Effect of number of concepts denoted by n on accuracy is shown in this slide. As we observe, at lower values of n, the precision is good but recall is poor. With increasing n, the recall improves without hurting the precision too much. As a result, the accuracy improves. As n increases further, the accuracy plateaus off. This slide summarizes the effect of n on the coverage. For more details, please refer the paper. Thank you.